estimation. Okay, again, we have the term for estimator and also estimate. So again, estimator is a function of the sample. Estimate is just a single value. So in this syllabus, we will learn about point estimate and also interval estimate. Okay. The first method that we will learn is on method of maximum likelihood estimation. Okay. Or we call that one as MLE. Okay. If we want to start with MLE, so that means we have to know what is the probability function. Okay, probability function would be known, and then you want to estimate the unknown parameter theta. So in this case, we use theta for the unknown parameter, and then we have a parameter space. The symbol that we use is just omega, and then you have a probability function, so fx theta, or you can write fx semicolon theta. So it's the same thing. So if we refer to the first definition, we will have a likelihood function. So likelihood function, we denote as L theta and then X, okay? L theta slash X. So it means that it's the product of Fxi theta. So we will have X as 1 theta times Fx2 theta until we have Fxn theta. So that is your likelihood. So we will maximize the likelihood function. So if you want to maximize the likelihood function, normally what we do is we change to log. Okay, so this is your log product. So it will become a summation of your log fxi theta. Okay. So then, okay. So the step, So then we will take a derivative. So if you have a single parameter theta, so you will differentiate with respect to theta, set equals to 0, and then you solve. So the same thing. If you have a multiple value, let's say you have 2 parameters, so then again, you differentiate with respect to theta 1, and then differentiate again with respect to theta 2, set equals to 0, and then you solve that one. Okay. So how you want to make sure that your MLE is the maximum likelihood estimation, you have a single parameter. So you can find the second derivative. If your second derivative of the log likelihood is negative, so that means your theta head is the MLE. So if the second derivative of the log likelihood is negative at theta equals to theta head. So that means your theta head is the MLE. Okay. So that is how we verify whether your parameter estimation is your maximum. Okay, maximum value, maximum likelihood estimation. So we just differentiate second derivative of the log likelihood function. Okay. Okay, so far we already done the exercise. Okay. So the exercise that we did is you can find, you already have the probability function, and then you can solve that one, and then you get a solution. Okay. But there is a certain case where if the equation where you differentiate ln L theta, differentiate with respect to theta, and then kita set equals to 0 are not meaningful. Maksudnya, you cannot solve that one. Okay, and this one does not yield any solution. So your MLE in this case will be an ordered statistic. Okay, so we have two type of questions. Okay, first maybe you can find you have the probability function and then you can solve that one. Okay, second you cannot differentiate that one, and then that your MLE will become an ordered statistic. Okay, kita go through dulu. So we already have this one. Okay, ini the step. So the first example that I already mentioned is on binomial distribution, but this one is just binomial 1p. So binomial 1p is just your n is equals to 1, parameter is p, so this is your Bernoulli distribution. Okay, Bernoulli distribution, the probability function is given as p to the power x, 1 minus p to the power 1 minus x. So you want to find the MLE. So first you write down your likelihood function. So product fxi p. Okay. And then kita substitute. We substitute. So you have px1, 1 minus p to the power 1 minus 1. px2, 1 minus p, 1 minus x2, and so on. Sampai you have n. Because we have sample size of n. And then kita simplify. The next step is you simplify So you have P to the power x1 plus x2 plus xn. So you have P summation xi. So the same thing, 1 minus P, but you have 1 minus x1, 1 minus x2. So in this case, you have summation 1 minus xi, or you can write down n minus summation xi. Okay. Once dah ada sampai sini, you take log or your ln. Okay, ln P. So you have summation xi, ln P plus n minus summation xi, ln 1 minus P. Okay, the next step, kita differentiate. Differentiate with respect to the parameter. So in this case, your parameter is P. So differentiate, and then again, set equals to 0, and then you solve, you have P head summation Si over N. So summation Si over N is just your X bar. Okay, your S bar. Normally we simplify. Okay, we didn't leave the answer as just summation Si over N. We just write down P is equals to X bar. Okay. Okay, again, yeah, to verify global maximum. So this one is just a Poisson distribution. Kita ada exponential negative mu, mu to the power x divided by x factorial. So the same step. Kita expand the likelihood function and then we simplify and then we solve lah. Okay. Take ln and then differentiate with respect parameter mu. Okay. Ini pun the same dia lah. Okay, example 1.3. Okay. Okay, so now kita go back dulu. Okay, I will discuss on the question that I already mentioned for your exercise. Okay, so if we look at the question, okay, so this is the question for the exercise for MLE. So the first question, you have distribution fx theta x to the power theta minus 1. Okay. Okay, most of you maybe in terms of writing too is not quite correct. So I will mention again. And then question number 2. So question number 2 is on gamma distribution. So in this case, I give you alpha is known. Okay, because we have 2 parameter here. Kalau gamma distribution, you have 2 parameter. You have in this case is alpha and also lambda. Okay. Since we have parameter alpha is known, so you just want to estimate your lambda. Okay, kalau alpha is unknown, so that's mean you need to estimate your lambda and also your alpha, which cannot solve macam tu saja. You need to solve iteratively. Iteratively, that's mean you need build up your programming. Baru kita boleh selesaikan dia punya MLE untuk 2 parameter. For this case, ya. Sebab dia tak dapat, dia kalau kita selesaikan, kita tak dapat a solid equation ataupun a solid value lah. Kita kena selesaikan secara programming guna macam Newton-Raphson lah yang kamu belajar. Newton-Raphson iteratekan and then dia converge kepada satu value. Itu kalau kita melibatkan 2 parameter unknown. Okay. So the next question number 3 is on binomial distribution. Okay. And then question number 4 is exponential distribution. And then I ask you to find the MLE for the probability x less than or equals to 2. Okay, ini just in terms, most of you can solve this one, but in terms of your, again, your writing though. Okay, tak berapa kena. Okay, question number 5, I think most of you get the answer. Simple je, kalau kamu Google soalan ni pun ada. Okay, so I will discuss question number 1 and number 3 kot ya. Number 3 and 4. Okay. So ini saya stop sharing dulu ya. Okay, let's see. Okay. We refer to the question number 1. I hope everyone can look at the question. Okay, ataupun refer back to the solution that you already write in Padlet. Okay, kamu boleh buka balik lah. Saya dah komen ya. For each group, I think we have around 10 groups. Okay. Dan cuba buat balik lah. Tengok balik apa kesalahan kamu kat situ. Okay, so the first question, so it just give you a distribution. Dia tak cakap lah mention taburan apa. Okay. So you just have question 1 Boleh nampak ya? This one. Okay, question 1, you have your fx theta is just theta x to the power theta minus 1. Okay? So you have your range is 0 less than x less than 1. Okay. So now you want to build up what is your likelihood function. Okay. So if you want to write your likelihood function, okay, kita ada L theta x. Okay, you have the product. Okay. I equals to 1 up to n, and then you have your fxi theta. Okay. So maksudnya di sini, you will have theta. Kalau tak sure, just tulis dulu apa maksud dia. Theta x1 minus theta minus 1, theta x2, theta minus 1, until you have theta xn, theta minus 1. Okay, kenapa Sn? Because you have a random sample x1, x2 up to xn. Okay, so next step you simplify. Sebab kita tak akan tinggalkan kita punya jawapan dalam bentuk macam ni je. Okay, you have to simplify. So that's mean you have theta, 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 you have n terms. Okay, because you have n sample size. So that's mean you will have theta to the power n. Okay, so the next one, okay, kalau boleh, you just write product xi, okay, I equals to 1 up to n. Kita letak bracket supaya tak confuse. Baru kuasa theta minus 1. Itu yang ada yang saya bulatkan setengah tu dalam kamu punya solution. Okay, you just write. Kalau let's say kamu tulis product xi tak ada bracket tu mungkin little bit confusing. Yang kita nak adalah x1 to the power theta minus 1, x2 to the power theta minus 1, and so on. Okay. So now, you have your ln. You take a ln. So that's mean, katakan ln L theta. Okay, kalau nak tulis macam ni pun, boleh. Mana-mana satu. Okay, so that's mean we will have, ini saya tukar terus ya. So you have n ln theta. Okay, theta minus 1. You have ln product of your xi. Saya tulis macam ni dulu. Okay, ln product of your xi. Okay, so now you want to find what is your bila kita differentiate with respect to theta. Okay. So katakan kat sini kita differentiate ln L theta d theta. So you have n over theta. Okay, plus, okay, differentiate this one, theta minus 1 ln product xi. So it just leave you as ln product xi. Okay, kat sini jawapan ni saya tak tukar lagi. Last baru saya tukar. Okay. So that's mean you set equals to 0. Okay, so you have n over theta equals to minus ln product xi. Solvekan. Ini akan tulis theta head Theta head negative n over ln product xi. Okay, kat sini nak tukar negative n summation ln xi. So that is your answer. Okay, kita ada theta head negative n ln product xi. So you will have equals to negative n over summation ln xi. Okay. Dan satu lagi take note, if you write summation ln xi is not equal as ln summation xi. Lain. Okay, summation ln xi maksudnya ln x1 plus ln x2 plus ln xn. Kalau ln summation xi, ln bracket x1 plus x2 plus xn. Maksudnya berbeza. So berhati-hati bila kamu tulis tu. Itu yang saya perasan bila kamu tulis kamu punya solution. Okay? Ada soalan tak on the first question? If you want to ask anything. Direct
Doktor.
Yeah.
Doktor, macam multiplication tu kan doktor?
Betul.
Kan daripada multiplication tu jadi submission. Macam mana tu doktor?
Dia macam ni, okay, Ilya.
Ah,
Loan
ah.
product XI ni, sekejap ya, saya pergi next. Saya pergi. Okay. Seperti kat atas nampak Okay, kalau loan product XI, product XI ni maksudnya loan kamu ni X1 darab X2 darab XN. Ataupun kita ambil lah, katakan kita ambil 3 loan X1, X2, X3. Kamu apply balik kamu punya tu, petua logaritma. Bila kita ada loan product, dia akan jadi loan X1 plus loan X2 plus loan X3 kan?
Ya doktor. Oh.
So that's why saya letak summation kat depan. Betul Macam kamu ada loan AB tu lah, loan AB. Loan AB maksudnya loan A plus loan B.
Oh, okey doktor. Nampak doktor.
Okay. Itu betul. Itu kesilapan yang selalu berlaku.
Ya,
Okay, tak salah kamu tanya tu betul. Mungkin yang lain tu tak berani nak tanya lah. Alhamdulillah kamu tanya. Okay. So that one loan product is mine. Okay. So now, okay. Tak ada apa ada soalan lagi? Kalau tak ada, kita proceed question number 2 pun ada salah. Okay, saya just go proceed for question number 2. Nampak kan? Ni kan? Okay. Okay, let's say question number 2. Okay, question 2, you have gamma distribution Okay, gamma distribution ni, okay, saya minta kamu dapatkan dulu dia punya density function apa Biasanya gamma ni kita pakai simbol ini alpha beta. So cuba Google nanti, dapatkan dulu density. What is your density function for gamma distribution? Sebab dia banyak-banyak bentuk ni, gamma distribution ni. Dia general formula sama, cuma cara kita tulis tu dia boleh beberapa bentuk PDF. Okay, tapi at the end tu benda dia sama je sebenarnya. Okay. So this one you have fx alpha lambda So that's mean kita ada, so the same thing. I equals to 1 up to n, kita ada fxi alpha lambda. Okay, kalau kita ada this one, maksudnya lah produk kamu, kita ada 1 over gamma alpha, lambda alpha, x alpha minus 1, exponential negatif lambda. Okay. So, bila kita tulis produk, maksudnya setiap satu tu, kita gantikan 1 over gamma alpha, lambda to power alpha, x1, alpha minus 1, exponential negatif lambda. Darab. Lepas tu 1 over gamma alpha, lambda alpha, x2, alpha minus 1, and so on. Okay, benda yang sama kan? Okay, sekarang kita simplify. Okay, sebab alpha kat sini, dia tulis alpha is known. Bila kita punya parameter alpha is known tu, maksudnya alpha is known, parameter tu dah jadi macam constant. Okay, kalau dia unknown, maksudnya kita kena estimate. Kalau dia alpha, dia is known, dia dah jadi macam constant value. Okay, so that's why kat sini, bila kita buat ni, kita akan dapat 1 over gamma alpha. Okay, ini saya to the power n, sebab kita n terms. Okay. Lambda alpha, lambda alpha, lambda alpha. So, kita ada lambda n alpha. Okay. So, ini x1, alpha minus 1, x1. This one, kamu akan tulis produk xi. Alpha minus 1. Ini dia akan jadi exponential negatif n lambda. Okay. Kamu akan elaborate lah. Maksudnya 1 over gamma alpha, lambda alpha, x1, alpha minus 1, exponential negatif lambda. Darab 1 over gamma alpha, lambda alpha, x2, alpha minus 1, exponential negatif lambda. Sampai kamu ada n term. Okay, ini cara kita simplify kan. Okay, simplify ni penting. Okay, penting sebab kalau kamu salah cara kamu nak simplify kan tu, dia mungkin efek dekat kamu punya yang bawah-bawah tu nanti. Dapatkan ln and so on. Okay. Okay, so this one. Okay, next. Kita tukarlah. Kita dapatkan kita punya ln. Kita ambil ln. Okay, katakan ln L. Alpha. Okay, Okay, so this one, n ln 1. So n ln 1 tu 0. Saya tertulislah. So n ln 1 tolak dengan n ln gamma alpha ni. So dia akan jadi negatif n ln gamma alpha. Okay, plus dengan n alpha ln lambda. Ini nombor 2. So plus alpha minus 1 ln produk xi. Okay, last. Okay, ln exponential negative n lambda. Just tinggal negatif n lambda. So that is your ln. Okay, so now kita differentiate. Kita differentiate ln terhadap lambda sahaja. Okay, sebab alpha is known. Okay, so maksudnya kita akan ignore lah the first part tu. Kamu akan tengok in the second term. Okay, n alpha ln lambda. So n alpha over lambda. 1 over lambda. So ini pun ignore. So yang tinggal adalah minus n. So set equal to 0. So n alpha sama dengan n lambda lah. Okay, so n cancel out. So you want to find is lambda head is equals to alpha. So last jawapan tu mesti letak ini head ni. Lambda head. Okay, lambda head is equals to alpha. Ini menunjukkan kamu punya MLE. Okay, so the same thing yang macam soalan tadi juga. Okay. So that is question 2. Saya rasa kalau salah pun dekat sini je. Dekat cara kamu nak simplify ni. This one yang ni. Okay. Dan lain tu saya boleh dapat lah. Tak ada salah sangat. Okay. Yang kita particular tu bila kita nak tengok yang sebab kita punya unknown parameter is just your lambda. So focus on your lambda tu. Okay. Itu question 2. Okay. Okay. Saya proceed question 3
Boleh doktor, boleh.
Boleh doktor.
Okay, so this one. So question 3. So question 3, ini ada salah dari segi probability function. Okay, dia dah cakap x1, x2, xn is coming from binomial distribution, binomial n pi. So maksudnya kalau saya simplifikan, saya akan tulis macam ni lah. xi binomial n pi. Okay, parameter kamu adalah pi Kalau untuk binomial, parameter dia pi, bukan parameter dia n. Parameter dia pi. Okay, n is your number of trial. Okay. So kalau kita ada binomial distribution, kalau saya akan tulis macam ni je sebab kamu dah tahu, boleh dalam bentuk factorial. Okay, ataupun saya tulis macam ni lah, n choose x, okay, pi to the power x, 1 minus pi to the power n minus x. This one. Okay. So now kita ada setiap satu tu. Ataupun saya tulis macam ni lah. Xi. So you have xi, ini pun xi, ini pun xi. So kita nak build upkan dia punya likelihood function. So that's mean you have independent I equals to 1 up to n, probability x equals to xi. So tambah kat depan ni je. Product I equals to 1, n choose xi, pi xi, 1 minus pi, n minus xi. So kalau kita expand, masukkan setiap satu tu, maksudnya you will have n x1, pi x1, 1 minus pi, n minus x1. Okay, darab. Tekan n x2, pi x2, 1 minus pi, n minus x2. Okay, n x1, xn, pi xn, 1 minus pi, n minus xn. Okay, so itu dia punya dia punya probability function lah kalau kita masukkan likelihood function dia. Okay. So sekarang ni kita nak simplify kan. So maksudnya di sini you will have again kita akan tulis balik lah L x So you simplify, okay, product I equals to 1 up to n. Saya akan tulis macam ni dah. N choose xi. Maksudnya n choose x1, n choose x2, produk produk benda tu. Okay. So pi ni kita ada pi to the power x1, pi to the power x2 up to pi to the power xn. So you darab pi, dia akan jadi summation xi. Okay. So this one, 1 minus pi. 1 minus pi. Kita ada n minus x1, n minus x2, n minus xn. Kat sini kamu akan ada ini n minus xi. Dia pelik sikit lah. Kita ada n. Okay, tapi kita ada summation. Sebab dia ada n minus x1, n minus x2, n minus xn. So you will have summation n minus xi. Okay. So the rest tu samalah. Kamu ada ln. So kamu akan ambil ln L pi x. Okay. So just tambah the ln product and choose xi ni. Okay, product I equals 1 up to n. Okay, plus summation xi ln pi plus summation n minus xi ln 1 minus pi. Okay. Yang kesalahan tu kat sini ni. Ini saya ni. Nah, itu. Ada yang betul, ada yang salah juga lah Summation n minus xi ni. Okay, yang the rest tu sama lah. Kamu differentiatekan, setkan equal to 0. So, differentiatekan this one. So, kamu ada d pi. So, again, summation xi over pi. Okay, you will have minus summation n minus xi 1 over 1 minus pi. So, bila kita simplifykan this one, kamu setkan equals to 0. Yang kamu nak dapatkan tu adalah pi head. Okay, pi head Okay, so this one, kalau kita ada this one. Okay. You will have summation xi over pi minus summation n minus xi darabkan dengan 1 over 1 minus pi. Okay. Kalau kita setkan equals to 0. So, if we set equals to 0. So, yang kamu ada adalah okay, kalau kita setkan equal to 0, so that's mean we will have summation. Okay, sekejap ya. Kenapa pula kalau macam ni? Okay, summation si over n. Boleh nampak ke? Boleh kan? Oh, saya tersalah apa ni? Okay, minus summation n minus xi 1 minus pi equals to 0. Macam mana ni hilangkan ni? Okay. So, bila kita selesaikan, kamu akan dapatkan kamu punya pi head ni. You will have this one summation xi. Lepas tu kita ada summation n macam ni. Okay, maksudnya kalau kita buka dia punya summation tu, dia akan jadi n lah. Okay, so that's why this one adalah x bar over n. Ini jawapan dia. Okay. Dah nampak ke saya punya ni? Okay, so you setkan, selesaikan equal to, setkan equals to 0. So you will have summation xi over n minus summation n minus xi over 1 minus pi, setkan equals to 0. So selesaikan dulu. Okay, setengah tu dah dapat. So pi head equal to summation xi over summation n. Summation n tu maksudnya n plus n plus, plus n tu kita ada n term. Ataupun kita boleh tulis n darab n lah. Okay. So in other words, saya simplifykan lagi summation xi over n dia adalah x bar. Divide by single n yang tinggal tu. Okay, so